Okay, let's try and tackle this problem. So given f prime equals this, find the stationary points and determine their nature. So what this means is we've got we don't know what the original f of x looks like, but f prime of x equals this. So we have no idea what the original function looks like. But from this, we can find the stationary points and we can determine its nature. So the stationary points occur when the gradient is 0, when it's flat. So we put 0 into here. So put 0 into here and find values of x where the whole gradient equals 0. So in this case, hang on. So in this case, if you put 1 into here, then the whole thing would be 0. So if you put 1 into here, this would be 0 times whatever this may be, times whatever this may be, the whole thing would be 0. So we know the stationary point would be will occur when x equals 1. So we know that the gradient, which is f prime, will be flat. So we don't know if it concaves down or if it concaves up. We don't know yet. All that we know is that the gradient will be flat. There will be no gradient at this point. And then if you look at this, when x is 3, if you put 3 into here, the whole thing would be 0. So we know that the gradient would be 0 at 3. And then if you put 4 into here, then the whole thing would be 0. So when x is 4, then you know that the gradient here would be 0. So remember, this thing here could concave up because the function could look like this. The function could look like this. The function could look like this. Or if you look at this, it could concave down. It could do this. We just don't know. The function could look something like this. There. You see, this one here could concave down, this one could concave up. We have no idea what the original f of x looks like. All that we know is f prime is given by this. Well, we've determined the stationary point. So if you want to know the height here, if you want to know the coordinates here, the coordinates will be 1, comma. Let's put. Actually, we don't know. We don't know the y coordinate. All that we know is that x equals 1 will be when the gradient would be 0. So now let's determine whether it concaves up or if it concaves down. So to do this, select a point just to the left of this. So I'm just going to select 0. So when we put 0, hang on. So to determine the nature of, to determine the nature at x equals 1, select a point to the left, select a point to the right, and let's look at the gradient just to the left of 1. So let's put 0 into the whole thing. What will f prime be? So put 0 into here. Put 0 into here. This would be -1. This would be -3. This would be 0 take away 4 squared. When you square it, it will be a positive. So you got a negative times a negative times a positive. So the whole thing would be positive. So what that means is to the left of 1, you're going uphill because the gradient is positive. So you're going uphill. So imagine you're standing at 0, you're actually walking uphill. And then let's see what happens when you're at the right of 1. Well, at the right of 1, what would the gradient be at the right of 1? So let's select 2, randomly select 2. So let's put 2 into here. So 2 take away 1 will be 1. And then put 2 into here. This would be -1. And then put 2 into here. I don't care what this would be. You square it, it would be a positive number. So positive times a negative times a positive, the whole thing would be a negative. So you're going to have a negative gradient. So whatever happens, at 2, you're walking downhill. You're walking downhill. At 1, the gradient will be flat. So what that means is here, to the left of 1, you're walking uphill, and then you will be walking on a flat surface, and then you will be walking downhill over here. So this must concave down. So the nature at this point at x equals 1, it will concave down. So let's use the same technique on the 3. So at 2, we know we're walking downhill. So at 2, we know that we're walking downhill. At 2, we're walking downhill. Well, if we're walking downhill, then there's no. Remember, there's a gradient of 0 at 3. So there's no way we can turn back around, because that would mean we've got to walk uphill. So what that means is this point here at 2, it will look something like this. And that which means at this point, the original function, this point should be higher like this. So our function will look something like this. Hang on, let me think. It would be 0 at 1, and then it goes downhill. So here, you're walking uphill, 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 uphill. At 1, it would be 0, and then you're walking downhill, downhill. So, downhill. And then at 3, we know it would be 0. Let's look what happens just to the right of 3. Let's select 3.5. Don't select 4, because we know it would be 0. We want to select a point before you reach 4. So let's see what happens at 3.5. Hang on. At 3.5, put 3.5 into here. This would be a positive. 3.5, take away 3. This will be a positive. Whatever this is, you're going to square it. It will be a positive. So at 3.5, you're walking uphill. You're walking uphill. So, hang on, at 3.5, you're walking uphill. So, to the left of 3, you're walking downhill. At 3, the gradient would be 0. To the right of 3, you're walking uphill. So that means it concaves up. So the nature at x equals 3, it would be a concave up. And use the same technique at 4. So at 4 here, we know the gradient is 0. Select any number to the right, 5 say, and see what happens. Are you walking uphill or downhill? I'm going to leave that for you to try it for yourself. But use the same technique, okay?